Cycle Stop Valve is the newest innovation in pump control. Leading the way in constant pressure technology, Cycle Stop Valve's patented action makes a variable flow pump from an ordinary constant speed pump. Easy to install on submersible pumps, turbine pumps, and all types of centrifugal pumps, the Cycle Stop Valve makes your pump match your needs exactly. Saving energy and eliminating water hammer, these unique valves hold constant pressure through any range of flow. Working with small bladder tanks, the Cycle Stop Valve replaces water towers, large hydro-pneumatic tanks, and variable speed drives. An entire city can operate on one 86-gallon pressure tank. Golf courses benefit from an absence of broken water lines. Nurseries can drip, spray, or flood as they choose. Industrial plants and high-rise buildings can have maximum flow when needed and small or no flow when idle. Even your own home can enjoy the luxury of constant pressure with the simple installation of a Cycle Stop Valve. Here's how it works. In this demonstrator, there is a 500-gallon per minute 10-horsepower submersible pump. Attached to the discharge of this pump is a 4-inch Cycle Stop Valve. The water line going to the irrigation or city wherever the water needs to go is attached to the Cycle Stop Valve. A small bladder tank with a pressure switch is tied into the main line. There is a 4-inch gate valve as well as a 3/4-inch hose connection to simulate large or small demands. There is an amp meter to measure current draw of the motor, a flow meter, and a pressure gauge. This demonstrator is set to come on at 10 psi and off at 15 psi. In this case, our 20-gallon pressure tank has about 5 gallons stored, and the pressure switch has a motor shut off at 15 psi. When the 3/4 hose connection is opened, the pressure in the tank drops to 10 psi after the 5 gallons in the tank is emptied. With the pressure lowered to 10 psi, the pressure switch starts the pump. The Cycle Stop Valve works as an automatic choke valve, restricting the flow from the pump to match the usage. Since a 5-gallon per minute hose is all that is being used, then 5 gallons per minute is all the pump is allowed to discharge. With the pump restricted to 5 gallons per minute, the current used by the motor is 28 amps. Since it was adjusted to 10 psi, the Cycle Stop Valve will hold 10 psi constant, allowing through only enough water for the 3/4 hose. If water usage increases, the Cycle Stop Valve will sense the pressure trying to drop below 10 psi and will begin opening as fast as needed to supply water as demand requires. As the gate valve is opened, simulating more use, the Cycle Stop Valve opens as well to instantly match the required flow. As the flow is increased from 5 GPM to 500 GPM, the current used by the motor increases from 28 amps to 58 amps. All constant speed pumps will do this. Electric current used is proportional to the gallons per minute being produced, not the back pressure. More back pressure means less horsepower. Complicated variable speed drives try to trick a pump into doing something it already does naturally. Restricting a full-speed pump with a valve can save as much energy as slowing the motor down. As the flow needed begins to decrease, the Cycle Stop Valve senses the pressure trying to increase above 10 psi and begins restricting output of the pump to match the usage. As flow is decreased to 200 GPM, the Cycle Stop Valve restricts the flow from the pump to 200 GPM. And the electric current used by the motor drops to 38 amps. When the use drops from 200 GPM back to 5 GPM, as with the hose connection, the Cycle Stop Valve restricts the output of the pump to 5 gallons per minute. Maintaining the 10 psi constant, while amp draw by the still full-speed motor reduces to 28 amps of electricity. The Cycle Stop Valve can never completely close. It is designed to always allow 5 GPM across the valve seat even when fully closed. This dampens the valve closure, eliminating water hammer even with extremely fast valve reaction speed. The 5 GPM slipping through the valve eliminates pump deadheading, making sure the pump always has sufficient flow for cooling. This 5 GPM is even enough to cool large submersibles because the amp draw is so low at this point that the pump could handle hot water, so 5 GPM of cool water is more than enough to keep the pumps and motors cool. When there is no more water being used, the 5 GPM forced through the cycle stop valve has no place left to go except into the small pressure tank. Then, 5 GPM is the rate that we fill the tank even though this is a 500 GPM pump. As the tank slowly fills to 15 psi, the flow is so low that the check valve is only open the thickness of a piece of paper. As the pressure switch shuts off the pump at 15 psi, there is no water hammer when the check valve closes. Now the tank again has 5 gallons stored and the pump is at rest. The cycle stop valve also absorbs the water hammer when the pump is again called on to start. Now watch how the cycle stop valve works on multiple pumps. Here we have a complete pump station with two 75 horsepower turbines and a 5 horsepower submersible. As we crack open a 10-inch butterfly valve, the release of water from the small tank lowers the pressure from 140 to 130 psi and the 5 horsepower sub starts. Holding 130 psi constant, the cycle stop valve on the 5 horsepower varies the flow from 5 to 50 GPM. As the butterfly valve is opened further, the increase in demand reduces the pressure to 125 psi, starting one of the 75 horsepower turbines. Opening the butterfly valve even further reduces the pressure to 120 psi, starting the other 75 horsepower turbine. Maximum flow for all 3 pumps is 1,550 gallons per minute. Pressure will remain constant at 120 psi until less water is needed. As the butterfly valve is closed to less than 750 GPM, pressure rises to 125 psi, shutting off one of the 75 horsepower pumps. Closing off the flow down to 50 GPM increases pressure to 130 psi, turning off the other 75 horsepower. Most large systems will remain at this pressure as long as at least 5 GPM is leaking somewhere. But if there are no leaks and no more water being used, then the 5 horsepower will slowly fill the small tank to 140 psi and be shut off. The 5 horsepower uses from 5 to 9 amps, and the 75 horsepower pumps take from 58 to 90 amps of current each. As flow increased from 0 to 1550 GPM, current draw from the 3-pump station increased from 0 to 189 amps. As flow was decreased, electric consumption decreased in proportion. Multiple pumps working together are always more efficient than a single pump trying to do multiple jobs. We make valves from 1 inch to 12 inch to fit pumps from 10 GPM to 10,000 GPM. From a single booster pump assembly to large multiple pump stations, the cycle stop valve is the key to smooth and efficient operation. Booster pump stations with flooded suction or suction lift requirements. Submersible pump stations require no grease or packing and are known for quiet operation. Turbine pump stations are workhorses, giving years of trouble-free service. Whether your pumping requirements are large or small, let Cycle Stop Valves show you how having constant pressure can be easier than you thought possible. Call your local Cycle Stop Valve distributor today, or see our webpage at www.cyclestopvalves.com.